Tonight, what we're going to be talking about are some fun calculations in two different types of formulas, empirical and molecular. Empirical formulas are the simplest whole number ratio of elements in a compound, meaning basically they're the most reduced. Okay, and a molecular gives us the actual number of each kind of atom in a molecule. And sometimes it may be the same as the empirical, or it could be a multiple of the empirical formula. So for example, if I had H2O2, this would be considered a molecular formula. Its empirical would be HO. Okay, but in the example of, let's say, water of H2O, this would be both its true formula, which would be its molecular, and it would also be its empirical because that reduced would be the exact same thing. So identify which of the following would have the empirical formula, which would be the empirical formula. So we've got CH4 and then C2H8. So this can be reduced as to CH4. So this would be an empirical formula because it's the most reduced. If we look at C6H12O6, you can reduce it to CH2O, which is not the most reduced, so that would be a molecular. CO2 I can't reduce anymore, so that would be an empirical formula. Give two molecular formulas for the following empirical. So this is the most reduced, and all you have to do is find a multiple of it. So let's say I'm going to multiply that entire thing by 2. So I would multiply both subscripts by 2, so it would be C2H4. Now let's say I want to multiply by 3. It would be C3H6. Okay, so these two would be molecular, this would be an empirical. What would be the empirical and molecular formula for the following structures? So it's easiest to find the molecular and then reduce it. So I've got 2 carbons right here, so I'm going to do C2, and I have 1, 2, 3, 4 hydrogens, so H4. So that would be my molecular or its true formula. The empirical would be if I reduced it. So that would be CH2, because I could divide both by 2. The following table illustrates, here's my empirical, here's my molecular. How do we get from the empirical to molecular? That's the multiple. In this case, we would have to multiply by 1, meaning they're the same thing. NaO to Na2O2. We would have to multiply by 2. And to go from CH2 to C6H12, we would have had to multiply it by 6. So that's all fine and dandy, pretty basic, but the main gist of this particular section is actually to calculate the empirical or molecular formula from data. What happens a lot is if you use these things called GCMS or gas chromatography, mass spectrometry, what happens is the machine, you insert a compound into it, and what it does is it actually gives you out the percentages of a certain element by mass in that compound or the substance that you gave. It can also do it by mass, so it either gives you the percentage or the mass, and from there what you can do is you can calculate the empirical and molecular formula. So basically, this information on the right here is the data that the machine would have given you. And from there, you can easily calculate by following these 5 steps, the empirical and the molecular formula. All right, so the first step is to change the percent of each element to grams, or if given actual masses, then keep them. So these are my actual masses, so I'm just going to keep them so I can move on to this next step. So I'm going to write down 13.5 grams of calcium, 10.8 grams of oxygen, and 0.675 grams of hydrogen. Next, you find the molar mass of each element using the periodic table. I'm going to kind of combine it with the step 3 is convert this mass into moles. So we're going to be converting the grams of calcium into moles of calcium, grams of oxygen to moles of oxygen, so on and so forth. So calcium's mass is 40.1 grams for every 1 mole of calcium. And so we get 0.337 moles. Personally, I would keep at least 3 to 4 numbers in order for this process to actually work out well. So you're going to keep 16 grams of oxygen for every 1 mole of oxygen. That equals 0.675 moles of oxygen. And then we're going to divide and convert this, which is 1 gram of hydrogen for every 1 mole of hydrogen. And so we get 0.675 moles of hydrogen. All right, now it says step 4 is divide all the elements by the smallest number of moles that you found in step 3. So in step 3, I found 0.337, 0.675, and 0.675. So I'm going to divide all of them by 0.337 since that's my lowest number. So for this guy, I get 1. For this one, I got 2. And that one, I got 2. Now create a formula from this ratio. So I have Ca1, O2, and then H was 2. All right. What I would like to point out is sometimes with these numbers that I have in the light blue, you'll get a weird number of like 1, and then another one would be 1.5, and then another would be 2, let's say. If this is the situation and you get a 0.5, what you need to do for all of them is multiply them by 2, because you can't have a formula with a 0.5 in it. Okay, so this would actually be whatever, 2, then 3, and then 4. So let's say it would be instead of C1H 1.5 O2, it would be now C2H3 O4. Okay. Another thing is sometimes you'll get like 1.33. Let's say oxygen is 1.33, hydrogen is 1, and then let's say carbon is 2. What you can do for this one is if you get anything by 0.33, 0.66, you're going to multiply all of these by 3. Okay, to get that little denominator out. And so you end up with, spacing out. You end up with 4 and 3 and 6. So in that case, if this was the lowest number ratio that you got for 4, you would end up with O4H3C6. Once again, I just made these up. It doesn't have anything to do with this problem, but you will be faced with that on your test and worksheets and so on and so forth. All right, let's try to do a molecular formula. So for molecular, remember this is its true formula. So the first step you need to do is add up the molar mass of the empirical formula. If the empirical formula is not given in the problem, then you got to find it first. So when I read this problem, I'm given the empirical formula of CrO3. So what I'm going to first do is find the molar mass of that guy. So CrO3, it's going to be 52 times 1 plus 16 times 3. So I get a total molar mass of 100 grams. Then divide the molecular mass by the empirical mass. What you're trying to do is figure out the molecular mass of this guy was 200 grams. So how many of these empirical guys of CrO3 is found in 200 grams? Well, each one is 100 grams. So all you have to do is take 200, divide by 100, and you get 2. Round this number to the nearest whole number. You should be really, really close to a whole number. So you should always be like 1.999999 or 2.05 or something like that, really close. So you get 2. Now multiply the empirical formula by this number to get the molecular. So we get Cr2O3. O6, because you're multiplying that CrO3 by the number 2. For this one, when you're doing the molecular formula, you'll never get those like 1.5s that I was talking about or the 1.33s or whatever. You'll never get that. If you do for this step number 2, you did something wrong. All right, and then let's try the last one, which is the same thing. We're doing a molecular formula, but in this case, I don't give you the empirical formula. So the first step is actually to figure out the empirical formula. So in this one, I have 80 grams of carbon, because remember the first step of the empirical says if you have a percent, change it to grams. So literally all you have to do is change that percent sign to grams. And then I've got 20 grams of hydrogen. Second step is to convert it to moles. Okay, and third step, it's find the molar mass and then convert it to moles. But we've got 12 grams of carbon for every 1 mole of carbon. And we have 1 gram of hydrogen for every 1 mole of hydrogen. So when you multiply that out, you get 6.67 moles of carbon, and you get 20 moles of hydrogen. The fourth step for empirical is divide by the lowest number, so 6.67, and you get 1 for that, and 6.67, and you get 3 for that. And then from there, you create your formula, which is C1H3. All right, so now I have my empirical formula. Now I can actually do my step 1 for my molecular. I'm going to find the molar mass. So this is 12 times 1 plus 3 times 1 equals 15. Now divide the molecular mass by the empirical. My molecular in the problem is 90. So I'm going to do 90 divided by 15. I get 6. and then round that to the nearest. It was perfectly 6, so that was easy. Multiply the empirical formula by this number to get the molecular. So CH3, I'm going to multiply by 6. So my final answer is C6H18. Now, a way to check it is to actually add up the molar mass of this molecular formula. Make sure that you get the 90 grams that it said you should. If you don't, you did something wrong. If you do, then you're probably right. All right, hopefully you have a basic understanding. Make sure you write down all these steps to calculating empirical and molecular, and all it is keep on repeating these same steps over and over again, and you'll get the right answer. Have a great evening.